So we're going to try some more word problems today, and these are all related to Algebra Standard L5. So go ahead and grab your calculator and your composition book, and let's go ahead and get started. All right, number one, Mrs. Best is hiring a moving company to move her to her new home. They are charging a rental fee plus 50 cents per mile driven. They estimated that it would cost her $64 to rent the truck when driven 48 miles. Write a linear model in slope-intercept form to represent the cost of using the moving company. So slope-intercept form, as we remember, is y equals mx plus b. Now, we have a little bit more information than we did in the last type of problem that we did, the type 1. On the type 1, we only had two numbers. One was our rate, which was our m, and one was our beginning value. Well, we don't know the beginning value, but we know the rate. So Mrs. Best is charged 50 cents per mile, so that's my rate. So my rate is 50 cents per mile. Now, I am not given the beginning value, but I'm given a point in time that it costs $64 to rent the truck when she drives at 48 miles. Well, miles is my x value and the cost is the y, because this right here, this equation that I wrote, y is the cost of this. So one little trick is whatever is after the word per, so in my rate, whatever was after per was the word mile, that's my x value. So when I have these two numbers, I'm going to write an ordered pair. So I'm going to have 48, comma, 64. So see how I got that? I knew that when she rents the truck and drives it for 48 miles, it's going to cost her $64. So y is the cost right here. So my cost is 64, that's my y, and 48 is the number of miles. That comes after the word per, so that's my x. Okay, so that just kind of helps us get it set up. Well, I need to go to slope-intercept form, but I don't have my b. But I have another equation. I have this equation. Y minus y1 equals mx minus x1. That's point slope form. Well, that's what I have. I have a point and I have a slope. So I'm going to use point slope form to begin with. Okay, so it's y minus, see how this is a y1? It's got that little number and this is an x1. That's my first point that I have. So this is my x1 and my y1. So y minus, I need the y1. Well, the y1 is the 64. And that equals m, which is 0.5 x, whoops, parenthesis, x minus, and then my x1 is 48. Okay, so now what I've done is I've taken the information from the problem and I've written an equation in point slope form. But they asked me for slope intercept. All I have to do is solve for y. So we've been practicing that a lot. So I'm going to distribute the 0.50 and then solve for y by adding 64. All right, so there's my equation. Y equals 0.5x plus 40. So this time I wasn't given a beginning value. So since I wasn't given a beginning value, I had to look at what I was given. I was given a point, so to speak, because I was giving a relationship. When I have this x, I get this y. So I wrote that as an ordered pair, and what helped me is I looked at my rate, and the word after the word per was mile. That tells me that's my x value. So my x value had to be the mile number, which is 48, and my y value was the total cost. So I knew my y was the total cost because it asked me to write an equation that represented the cost of moving. Okay, what is the rental fee? Well, if they charge us a rental fee plus 50 cents per mile, I just look at the equation I just wrote. And my rental fee is $40 because that's the beginning amount. So Mrs. Best has to pay $40 plus 5 cents or 50 cents for every mile. And then the final question says, if Mrs. Best's home is 150 miles away, how much will the total moving charge be? So I take my equation that's written in slope-intercept form, And I know my new home is 150 miles. Miles is the X number. We just talked about that. So I'm going to take out the X and replace it with 150. Because think about it. If she has to pay 50 cents per mile, I'm going to multiply the 50 cents times the 150. That makes sense, doesn't it? Okay. So I know that half of 150 is 75 plus 40. So Mrs. Best is going to pay $115 to move her family from one location to the other if it's 150 miles away. All right, switching gears here. David's favorite snack is jelly beans, just like President Reagan. He found a discount store that has the cheapest price on jelly beans in Lafayette. DeCount Candies charges $3.50 per pound for jelly beans. But David needs to pay an entry fee upon each visit to the store. David's last purchase was 7 pounds of jelly beans for $29.50. Write a linear model in slope-intercept form to represent the cost of the jelly beans. Okay, I bet you can do this. Write your M. Your M is the rate. So see if you can do it. What is the rate? Ha! Did you get it? Did you get $3.50? That's the rate because there we go. Now, they didn't give me a beginning value because it says he has to pay an entry fee to visit the store, but I don't know that. But I have a piece of information. 7 pounds of jelly beans cost $29.50 total after he pays the entry fee. So I have a point. I have an X and a Y. Now remember what I told you. Whatever word comes after the word per is your X. So look at the word per. Here it is. X is the pounds. So it's going to be pounds. And then Y is the cost. So look at your piece of information here. I have 7 pounds for $29.50. So my 7's going to go here and my $29.50 is there. So now I have slope and I have point. So when I look at my equations, I have an equation that's called point slope form. Point slope form looks like this. Y minus y1 equals m parenthesis x minus x1 close parenthesis. So my ordered pair for my problem is my x1 and my y1 because I want to leave the plain looking x's and y's in my equation. Okay, because we don't have equations that have those little ones under it when we're done, right? That's just kind of a tool to help us. So what I need to do is I need to substitute. So I'm going to leave this y, but for y1, I got to come to my ordered pair and grab the y1, which is the $29.50. And then I put my equal sign. I need my m, which I already have figured out is $3.50. And then I have x minus, and then I need my x1, which is right here. It's 7. Okay. But they want it slope-intercept form. All that means is solve for y. So don't forget to distribute. So I have to distribute this $3.50 to both the x and the 7. So what I need to do is grab my calculator and do $3.50 times 7. And I get $24.50. Okay? Now I'm so close. To solve for y, I just add $29.50 to both sides. And I get y equals $3.50 x plus, since I have a positive and a negative, I subtract. Oh, that's pretty easy. I get $5. Ah, they charge a $5 entry fee because remember they charge $3.50 per pound plus an entry fee into the store. So in our case, it's $5. So what's the entry fee? Well, that's the beginning value right there, $5. And then how much would David spend for 10 pounds of jelly beans? Well, if it's $3.50 per pound, I have to plug the 10 into the x. So I want to find out the cost, which is the y. So I take $3.50 times 10 plus the $5 entry fee. Wow. So he's going to spend $35 plus $5. He's going to spend $40 on candy. $40 on candy. You would never do that, would you? Would you spend $40 on jelly beans? That's a lot of money. All right, moving on to number 3. At the 6,000 feet level of a mountain, it is 76 degrees Fahrenheit. On this mountain, the temperature drops 9 degrees every 2,000 feet increase in elevation. Write a linear model in slope-intercept form to find the temperature T at any elevation on the mountain. Okay, they're trying to be a little tricky here. Instead of per, they're saying for every 2,000 feet. So here's my rate. The temperature drops 9 degrees for every 2,000 feet. So think about it. My rate, on the last problems, it was the cost per pound. Here, it's 9 degrees for every, not 1 foot, but 2,000 feet. So my rate is going to be a fraction. It's going to be 9 over 2,000. But now I have to decide, what is the significance of the word drops? Well, think about it. The temperature is going down, so it's being subtracted. So my slope is negative 9 over 2,000. Did you catch that? So my rate is negative 9 over 2,000 because it's dropping down. Now, they want me to go in slope-intercept form, which is y equals mx plus b, but I don't have a beginning value. Instead, they've given me two ordered pairs, or they've given me two values. So I have to write an ordered pair. Okay? So whatever comes after the word per was what my x value was. And so this time it's feet. So I have feet here, and I have degrees. Okay? It says write a linear model in slope-intercept form to find the temperature. So my temperature, whatever I'm trying to find there, is my y value. So my degrees is going to be my temperature. Okay, so now look at your information that we have. At 6,000 feet, it's 76 degrees. That's my piece of information. That's my ordered pair. Which one is the x? Well, the x is the feet, which is 6,000. And the degrees are going to be 76. So that's my ordered pair. Now, I have the slope, and I have a point. So that means I have to use the point-slope form. So I have y minus y1 equals mx minus x1. Well, again, this first y stays. I need my y1. Well, this ordered pair is my x1 and my y1. So I'm going to grab the 76. Now I need my m, which is negative 9 over 2,000. You're not afraid of that fraction, are you? No. And then x minus, I need my 6,000. Okay, now we're just going to start distributing, but we're not going to be afraid of this fraction because we've known how to use fractions since we were in elementary school. So people might not like them, but you still are pretty good at it, I'm sure, or you wouldn't be in this class. So we have negative 9 over 2,000 x. Then I have a negative times a negative, which is a positive. Now, if you remember this little trick here from fractions, I have 2,000 on the bottom and 6,000 on the top. 2,000 goes into 6,000 3 times, so it's really just negative 9 times negative 3. So it's really just 27. See how harmless that was? Now, if you didn't remember that, remember fractions are just division problems in disguise. So I'm going to do negative 9 divided by 2,000 on my calculator and push enter. And then I'm going to multiply that by negative 6,000. And I also get 27. So you can do it either way. It's up to you. Now I'm going to add 76 to both sides. So I get y equals negative 9 over 2,000 x plus, then I just have to add 27 plus 76. And I get 103. So my equation is y equals negative 9 over 2,000 x plus 103. And then it says, what is the temperature at 18,000 feet? Well, I'm just going to plug in an 18,000 for my x because remember the temperature drops every time you go up 2,000 feet. Okay, so I'm going to just plug this in. So I'm going to come down here in the blue. So I have y equals negative 9 over 2,000, but I'm going to plug in an 18,000 plus my 103. Okay, now we can do that little trick. 2,000 goes into 18,000 9 times. So I really get negative 81 plus 103. And if you didn't like that little trick, you could do negative, let me clear my calculator here. You could do negative 9 divided by 2,000 and push enter. And then you multiply that by 18,000. and you still get negative 81. So now when I add that to 103, I get 22. So my answer is 22 degrees, and that makes sense because the temperature is dropping. So the further you go up the mountain, the more the temperature drops, or not the more the temperature drop, but the temperature will drop. So for every 2,000 feet you go up, it drops 9 degrees. So when I go up and up and up, it gets colder and colder and colder. Okay? All right, moving on to part C. What is the temperature at 1,000 feet? Well, I'm going to plug in a 1,000 for my x. So I'm going to do negative 9 over 2,000 times 1,000 plus 103. Okay? So what I'm going to get is, well, 2,000 and 1,000. So this time, I can cross off those 3 zeros and those 3 zeros, my little trick from elementary school. So I get negative 9 halves plus 103. Now don't worry about that negative 9 halves. You have a calculator, or you can just think about what negative 9 halves is. So it's going to be negative, whoops, clear my calculator, negative 9 divided by 2, which is negative 4.5 plus 103. And I get 98.5. 98.5 degrees. Now it says, would you be adequately dressed at 1,000 feet and 18,000 feet at the same time? Explain. Okay, so let's think about it. We had 98.5 degrees is what the temperature was. And look at what the other temperature was at 18,000 feet. So answer that question real quick, and we will talk about that when we get back to class. All right, we're moving on to the third type of problem. And this time, you're not given the rate, and you're not given the beginning value. Instead, you're giving 2 points of time. So you're given an x1 and an x2. All right, so Allison called the Dancing Feet Studios to find out prices for dance classes. Aside from the registration fee, the cost for 7 lessons is $82, and the cost for 11 lessons is $122. Okay, so I have two relationships. So it says, write a linear model to find the total cost for L lessons. Okay, so what they're wanting me to do, so instead of doing y equals mx plus b, they're wanting me to write it like this. C equals ml plus the beginning point. Okay, so these are the two things that I'm going to be able to find out. All right, so here's what I know. So if I'm wanting to find the total cost, that's my y value. So I'm given 2 ordered pairs. So I'm really given an x1 and a y1. And whatever I'm trying to find out for my equation, I want to find the total cost. That's the y value. And the number of lessons is my x value. So the first order pair, it says the cost for 7 lessons is $82. So 82 goes here, and that relationship is 7. 7 lessons cost $82. Okay, so now I should have another ordered pair. Okay, so I'm going to have an x2 and a y2. So the next relationship, it's $11, or 11 lessons cost $122. So that's my other ordered pair. Now wait a minute. I have y equals mx plus b. I don't have my slope and I don't have the beginning point. But then that other form that I had, which was y minus y1 equals m, x minus x1, I don't have my m. But I can find my m, can't I? Because to find the slope, I'm going to take y2 minus y1 over x2 minus x1. So I have been given the information from these two values. I've been given 2 points, 2 ordered pairs. I can find my slope. So I'm going to do that. So my y2 is 122. See, it was right here. Minus my y1, which is up here, it's 82. Over my x2, which is 11, minus 7. Okay, so I just have to do my calculations, and then I'm going to have my slope. So I have 122 minus 82, and so I get 40. And then I have 11 minus 7, and I get 4. So my slope is 10. Okay, so I've got one piece of information. I've got m equals 10. Got that. Now, I need to find my b, but I only have two pairs. So I'm going to use this formula over here. I'm going to use my point slope. So I'm going to do y minus, and I need my y1. Well, my y1 is 82, and that equals my m, which is now 10, and then it's going to be x minus, and my x1 is 7. Now I just have to solve for y. So I have y minus 82 equals 10x minus 70. And I add 82 to both sides. And I'm going to write my answer up here. I get y equals 10x plus 12. So what that tells me is it costs $10 per lesson, plus it cost me a $12 registration fee. So that's what they're asking for in the next problem. What's the registration fee? It's $12, and the class fee is $10 per class. So how much would it cost for 4 lessons? So I have y equals 10x plus 12. Well, that means my x is going to be 4. It's going to be $10 times 4 plus my 12. Well, that's 40 plus 12, so that's 52. So it's going to cost me $52 if I want to take 4 lessons. Now it's asking about 21 lessons. So I literally come back to my equation, and instead of the 4, I plug in the 21. So go ahead and do that. Pause the video, and then when we get back in class, we will check the answer. All right, moving on to number 2. In 1996, there were approximately 275 students in the Jefferson Marching Broncos. In 2002, that number increased to 305. Assume the number of students is linearly related to the year. Write a linear model to the number of students according to the year where x equals 0 corresponds to the year 1996. All right, so I have two pieces of information. In 1996, there's this many students. In 2002, there's that many students. But here's a little catch here. They want me to use 0 for 1996. So my ordered pair is going to be 0, 275. And that's my x1 and my y1. Well, if they want me to use 0 for 1996, what is 2002? Well, if 96 is 0, 97 is 1, 98 is 2, 99 is 3, 2000 is 4, 2001 is 5, and 2002 is 6. So I have to use 6 for 2002 and then 305. If you don't understand what just happened, pause that and think about it for a second, and then we'll get going. All right, so this is my second point in time. This is my x2 and my y2. They want me to write a linear model. Okay, well, the only thing I can do when I'm given 2 points is to use the slope formula. So my slope is y2 minus y1 over x2 minus x1. So my y2 is 305, and my y1 is 275. My x2 is 6, my x1 is 0. Okay, so when I do this, 305 minus 275 is 30 over 6, which is 5. So my slope is 5. Okay, so now I have to write an equation. But whenever I have, what do I have now? I have the slope and I have 2 points. So I'm going to use point slope. So I have y minus y1 equals m x minus x1. And I start substituting. Remember, the first y doesn't go anywhere. My y1 is 275. That equals my m, which is 5. And then x minus 0. Oh, good. So I get y minus 275 equals 5x. So my final form, when I add 275 to each side, is 5x plus 275. So that's my linear model. How many students will be in the marching band in 2015? Well, if 2002 is going to be year 6, 2003 is year 7, 2004 is year 8, 2005 is year 9, 2006 is year 10, 2007 is 11, 8 is 12, 9 is 13, 10 is 14, 11 is 15, 2012 is 16, 2013 is 17, 2014 is 18, 2015 is 19. That's going to be year 19. Okay? So in 2015, how many kids are going to be in there? So what this tells me is that's going to be when x equals 19. So I literally take my equation, y equals 5x plus 275, and I take out my x and replace it with a 19. So I get 5 times 19, which is 95, and I add that to 275. So there should have been 370 kids in the marching band. So 370.